So on Saturday, this is paper 1. Alfredo and Beatrice, A and B, play 6 different games against each other. Each game, one of the 2 wins. So win or lose, we have only 2 options, outputs, and probability that Alfred wins any one of these games is 2/3. Alfred wins exactly for the game. So let's call it A. Probability A wins exactly 4 out of 6. So 6 to 4 wins 4 times, lose twice. So 6 factorial, 4 factorial, 2 factorial, and 2 to the power of 4, 3 to the power of 6. And here 6 and 5. Now we don't have this one, and we have only 3 here. And 6, we have 5 here. So this is 243. And 2 times 5 times 2 to the power of 3, which is 80. So it's shown. Number B, explain why the total number of possible outcomes for the result of the 6 game is 64. Because the output is just win of Alfred or Beatrice. So each game has the 2 different outputs. And we have 6 games. Therefore, it's 64. By expanding 1 plus x to the power of 6, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. So 1, 6, 15, 20, 15, 6, 1. And here, because we want to make it 64, so let's put 1 into x, then 2 to the power of 6, 1, 6, 15, 20, 15, 6, 1. This is this one. And yeah, because this one, the numbers from this Pascal triangle, this is 620, this is 621, 622, blah, 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 625, and 626. So this is equivalent. State the meaning of this equality in the context of the 6 games played. So each of the game, so all possible outcome, the number of is 64. Here, the possible outcomes means, like for example, Alfredo can win 0, 1, 2, 3, 4, 5, 6 games out of 6 games. So if he never win, and if he win only once, twice, 3 times, 4, 5 times, 6 times. So this is all possible outcome. Because they play just 6 games, how can they make different outcomes? But I just explain it from the Alfred side, but Beatrice also same result. Out of 6, he can win 0 to 6 times. So number C. The following day, Alfred and Beatrice play 6 games again. Oh, so yesterday it was like this, and another 6 games happens today. So assume that Alfredo still 2/3. Find the expression for the probability of Alfred wins 4 games on the first day and 2 on the second games. Like this. Okay, so on the first day, so now we are assuming that their result, like 2 days' result, are independent. So Alfredo win 4 games for first day and let's make it like this: 4 wins and 2 wins for second day. So the first day, 6 to 4. So 2 over 3, 4, and he need to lose twice. Times, because I assume that they are independent, so we put them, we multiply them together because it's independent event. So 6 to 4, 2 over 3 to the power of 2, and 1 over 3 to the power of 6. No, I mean 4. So this and this actually is the same. So because it's very symmetrical, this and this. So we can call it 6 to 4 or 6C2, whatever it is, it's the same. So 6C4, 2 over 3 to the power of 6 together, and 1 over 3 power of 6, 2 and 4, 6. So this is the answer. II. Using your answers to CI, 6 similar expressions write the probability Alfred wins total 6 games over 2 days as the sum of 7 probabilities. Okay, so let's make them pairs, number pairs. So no win on the first day and 6 wins on the second day. 1 and 5, 2 and 4, 3 and 3, 4 and 2, 5 and 1, and 6 and 0. This is the case he can make total of 6 games over the 2 days. So then this is the ones, the like 6 to, no, I mean, sorry, because this and this together, I mean, so it's squared. So the first one, 6 to 0 and 6 to 6 is the same. So 6 to 0 squared. So 2 over 3, 6, 1 over 3, 6, plus 6 to 1 squared, 1 over 3, 2 over 3, 1 over 3. Now, yeah, we understood. 2 over 3 to the power of 6, 1 over 3, power of 6 is just common. So 6 to 0 squared, 6 to 1 squared, 6 to 2 squared, blah, 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 6 to 5 squared, 6 to 6 squared. So now hence prove that. This is just, yeah, because now we thought about this is the 2 different days. But just let's think about like this is just a total 12 games and he can win 6 times. So this is exactly like out of 12, he will win 6 times, and 2 over 3, 6 to the power of 6, 1 over 3, power of 6. So in this case, we can show that this and this are same. So we can say the result is equivalent to the result when we consider this situation, the 6 winning out of 12 games. So it's proved. Number D, Alfredo and Beatrice plays n games. Number of games Alfred wins. Expected value of R. Yeah, because we make the xn probability multiplication for the expectation values. So find the value of A and B. Let's make it. So for example, he can win from 0, 1, 2 to n. This is the Alfredo, the number of wins. Probability A is A. So this is n to 0. He never win. And 2 over 3 to the power of 0, 1 over 3 power of 1. And here NC1 2 to the power of 3, 1, 1 over power of 3, n minus 1. Oh, here n. Here NC2 2 to the power of 3 to the power of 2, 1 over 3, n minus 2, blah, blah, blah. NCN 2 to the power of 3 to the power of 0. No, I mean n. 1 to the power of 3, 0. So now the expectation we are making 0 times nc0, 2 to the power of 3 is 0, 1 to the power of 3 to the power of n, plus 1 times nc1, 2 to the power of 3, 1 over 3, and minus 1, 2, nc2. Yeah, this is what we did always whenever we deal with this discrete probability random variable to find the expectation. NCN 2 to the power of 3 to the power of n, 1 to the 3, 0. So this is just, we can write it like this. So from here, this, or R, and yep. So R starts from 0 to n. So this is R, NCR, makes sense. But from here, you know, we always have 3 to the power of 0, 3 to the power of n, 3 to the power of 1, 3 to the power of n minus 1. So altogether, always we have 3 to the power of n. So 3 to the power of n, sorry. So 3 to the power of n, and 2 to the power of r. So now we know A is 2, B is 3. So by differentiating the expansion, prove that expectation is that one. Okay, let's go. So 1 plus x to the power of n is nc0x, nc0, nc1x, nc2x squared, blah, 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 ncn x to the power of n. So let's find the derivative on both sides. n 1 plus x n minus 1 becomes, we don't have this anymore. So nc1 2 nc2x plus n ncn x n minus 1. This is the result of the derivative. So just to make the similar result with that here, because now we are looking for the expression of this. So now, anyway, we don't need this, so it's okay. So we need 3 to the power of, so let me just multiply them x on both sides, because we have 1, 2, but we need 2 and 2, 1 and 1, but we have 2 and 1. So we need 1 x on both sides. X, x. So now like this. We have to the power of n. So let n multiply 3 to the power of n on both sides. And let x be 2. Then 2 and 1 plus 2 and minus 1 over 3 to the power of n becomes 1 nc1 2 and 3 to the power of n plus 2 nc2 x squared 2 squared and 3 to the power of n plus n ncn x 2 to the power of n 3 to the power of n. So we made all the form same. So now this is the result. So 2 expectation of x becomes 2n 3 and minus 1 over 3 to the power of n. So when we cancel them out, we have only 1 3 on the denominator, like this. So it is shown. And number 14. Chloe and Selena plays a game. Each of 4 cards showing capital letter A, B, C, D. So Selena shuffles her card and face down on the table like this. And she turns them over one by one. And she is looking whether her card matches with Chloe's card directly above. So if she has A here, then that's good one. Chloe wins if no matches occurs. Otherwise, Selena wins. So Chloe wins the probability. So no matches occurs. So for example, let's call it 1, 2, 3, 4. So the first card can have, just to make Chloe wins, first card can have B or C or D. Because we cannot have A to make Chloe win. And now, if we have B, now we have the case of A, C, D. So for the second, we can have A, C, D. If we have B and A here already, then now we have C and D, but we cannot have C and D because we need to avoid the same card. So D and C is only possible way for the first line. And if we use B and C here, now we have A and D. So we cannot put A and D because in the case D matches together. So we need to make a D and A. So if we have B and D here, now we have A and C. So we need to make A and C. We cannot make C and A. So this is the case of Chloe winning if we have the first card with B. So now let's say first card was C. Then we have A, B, D. So the second card can be A and D only because B cannot come. So if we have A and C here, we have B and D. So this is the only way, B and D. Let's just make it like this, just to make sure. So we cannot have A, the first branch. We cannot have B, we cannot have C, and we cannot have D. So when we have C and D for the first two cards, then we have A and B. So now we can have A and B or B and A because there's no matches. And if we have the first card C here, D, then we have A, B, C. So we can have A and C. If we have A and D, like DA, then we have BC. So we can have only BC. We cannot have CB. And AD, only B and C, no C and B. So if we have D and C here, then we have A and B or B and A. So this is all. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So you may think this is too manual. But sometimes this is the best way to consider the all cases without because when you just calculate this one without the repetition or avoiding all these cases is very complex, I think. So whenever I see this question, quite oftenly, I use this manual method. So anyway, so now she wins 9 cases out of. Selena can have the cards, the first card, without just considering the who wins. Selena can have 4 cases on the first card, and 3 cases for the second card, and 2 and 1. So 6, 24. So 9 cases, Chloe wins out of 24 cases. So that's why this is 3/8. So now she repeats the games, the play total of 50 times. So this is now binomial x following the binomial distribution 50 times with 3/8. Chloe wins. Mean 50 times 3/8. We call it expectation of x. So 75/4. Variance of x is NP 1 minus P. So this is already NP. 75 over 4 and 1 minus p, 5 over 8. So 32, 375 over 32. That's it.